live.
My grandma's dead.
Review day. There we go. I apologize that these look slightly different than what we've been used to doing with the worksheet, but I just made them bigger. I felt like those were too small. I want to give you plenty of room. Tucker, I got you.
Happy anniversary. That's why I'm on the phone with Springer. I'm starting to cry, but she's actually losing her mind.
All right, so check it out. Define the median of a triangle. So let's talk about that. Median's a line segment, right? So it's a line segment. But not just any line segment. What 2 points does the median connect? Connecting the... Right. What 2 points does the median connect? The median. 2 points on a triangle. Yeah. The midpoint and the vertex. We can be more thorough than that, right? The vertex and the midpoint of the opposite side. But honestly, if you start on a vertex, if you try to draw a line to this midpoint, right, you're just going to end up getting this, right? And if you try to draw a line to this midpoint, you're going to get like that. So the only midpoint you can really draw a line to is here. So we'll let that happen. Yeah?
Can you zoom in a little bit?
I zoom in.
Yeah.
There you go. Only we guess closer to the front. Only.
No, you're getting a little.
All right, so let's draw two of them. So I don't know. I'm going to connect C to this down here. Whenever you make a new point, make sure you label it with something. So let's do M for Maddie. And for midpoint. Wow. Wow. Now, is that a midpoint just because I say it's a midpoint? No. I'm going to label my diagram to make it look like a midpoint, right? Cuts it into 2 equal parts. Now I got to draw another one. So what do you want to draw from, A or B?
A.
All right. From A to the midpoint of the opposite side. So let's go here, and we'll do T for Tucker. We got 2 midpoints, or 2 medians on there. We could draw a third. It would intersect here, right?
That's all that's there.
What's the median theorem? It says. So the theorem is what we've been learning and talking about. We just haven't given it a name. So the median theorem is this. So let's make this intersection point something. Let's call it, we can't call it C for centroid because we already used C. Let's do D for doc. All right, so centroid, duh. So what it's saying based on this diagram is that 2 times dm.
Can you move it over?
Oh, yes I can, I'm sorry. 2 times dm will equal CD. Right, if we double this, we get this guy, right? We've been talking about that.
So what is the point that's labeled D? What is that called?
D? D is the centroid. Let's talk about that, yeah. Let's write that down. Centroid. D is the centroid.
Oh,
Right? So if you double this, you get that, right? It's also true that if you were to double dt, right, you get 80. Are dm and dt always congruent? No. They could be different, right? That could be 3, which would make that 6, and that could be 4, which would make that 8. That happens.
I have a question.
What?
What's that say below midpoint and
And the vertex. Vertex, remember, is the points in the triangle, right? The middle of the angles, if you will. The intersections of the segments of the triangle.
So is that all we have to do for that?
I don't know. What do you think, Ms. Bechtel? All right. She approves, and we're good. If CD is a median, okay, so they're telling you CD is a median. If CD is a median, first of all, what can I add to my diagram? If CD is a median, what do we know?
A, D, and B.
Yeah, buddy, they must be congruent, right? Ooh, Ms. Bechtel, we forgot something. AT is a median only if those two sides are cut in half, right?
I was gonna ask you.
You're gonna ask me?
I was gonna say.
Why didn't you, Zach?
Because I just figured out like
We're setting that one up for you, right? You spike it, bump, vector set, spike. Where were you?
I'll spike this one.
CD's a median. Okay, cool. So we know that, right? They tell us AB. AB's all this, right? They tell us AB's 12. That's 12. We want to find the value of BD. That's what we're looking for, right? So, could be 6, right?
Maybe.
Maybe. We don't know for sure. We should probably do the work. All right. So, AB equals BD times 2, right? So if we divide by 2, checks.
Yeah.
Okay, good, good. Solid.
So this is all we have to remember.
BD 6. You guys see why it is? This is half and half. The whole thing's 12. That's 6, right?
You just made it seem like we had to learn a lot more.
He fooled you.
This is one of the easier ones.
You just all do that.
First of all, we haven't even used letters yet, like algebra, right? Second of all, we haven't talked about the median itself. We just talked about the segments that cuts in half, right? So, if AD is the median, what does that tell us about our diagram? What can we add, East?
What?
If AD is the median, what do we know?
B, D.
Thank you, Corinne.
I didn't play eyes.
Couldn't wait for you, East. I'm sorry.
Sorry.
BD is 3, it says, so let's do that. What does that tell us about CD?
It's like,
CD?
That was 3.
That's 3. The whole thing's going to be 6. That's true. We're going to find the value of BC. What's that going to be?
6.
Can we just pause for a second and reflect on how amazing that looks? That could be the side of a
Wow.
violin right
That
there.
is so good.
That could be the side of a
You can
violin.
do another one for Batman on the other side.
I can't do it this way. I'll screw it up. Don't ruin the perfection. If I could like stamp it or something, like flipping it, it'd be good. So BC must be 6. What?
Like, I said, what is that like little thing called?
A squiggle? This is called a bracket, right?
Oh.
But when it comes to instruments, I think it's called an F curve. You'll see, I don't know if it's actually called an F curve. You'll see these things in violins, though, like that. Right, they'll cut
Yeah.
out, right? And that's called an F hole, which, you know, lots of jokes there. All right, flip the page. You know what the Latin word for oboe is? Hot boys. You know what a trombone used to be called? Sackbut. What instrument do you play? I play the sackbut. All right. CD and AE are median. So right away we should know that these must be the same, right? And these must be the same. Right? Because they're medians. So D and E must be midpoints, right? They tell you that DF is dose. Ooh, now we're talking about the insides of the triangle. Then we should define the value of CD.
I got it.
Is that showing up as orange? Kind of. Kind of. Let's see, can I? That really helped. That helped a little bit. We'll leave the light on. All right, Eads, walk me through your logic.
Well, the D and F is 2, and the whole, and then C and F has to be double what? F
Exactly.
is.
That's median theorem, right?
So, yeah, so C and F would be 4, which would make it 6.
So careful, CF is 4, but they're not asking about that. They want to know about CD.
Yeah.
So what's CD? I know you got it, but
Oh.
6, right?
What about 6?
6 seems to be a very popular answer. I just want to make sure. That's all. I don't know.
No, I was there.
6 is a very popular answer today.
Just easy.
AD and BE are medians. First thing you should do, mark congruent segments, right? AD cuts this in half, so we got a segment here and a segment there that match. And then it must be true that these are the same as well, right? BF, well that's 9. That's 9. Squiggles are on point. Find the value of EF. Well, EF's this little bit right here. Now, which part is longer? Is it going to be the part from the vertex to the centroid, or from the midpoint to the centroid? Vertex to centroid. That'll always be the longer part. So if this is 9, that's going to be half of that, right? What's half of 9? Doc, what's 9 divided by 2?
4.5.
4.5. You can write 4.5, or you can write 9 over 2, right? So EF is 9 over 210. Just kidding, just 9 over 2. 9 over 210. What's the area code of?
What?
Beverly Hills.
It's close enough.
It's a TV show, 90210.
Oh, I watched that show.
Wow. Still relevant. All right, here we go. Next. Oh no, we're finding the value of x. C, D, and B, E are medians. All right,
I
well,
cannot do this.
here we go. It tells you that EF is x plus 3. Looking good, looking good, looking good. And it tells you EB, well, that's 36. That's 36. We want to find the value of x. Well, this is from the midpoint to the centroid, right? So that's the smaller piece, right? So this guy's going to be double that. If I told you that was 3, this guy would be 6, yeah? Well, when we double it, we double everything, right? Every term gets doubled. So instead of x, we're going to have what? 2x, right? 2x. And then instead of 3, we're going to have 6. So 2x plus 6. That makes sense? It's double. If I did x plus 3 plus x plus 3, you put it together and get 2x plus 6, right? We just doubled it.
So is the vertex to the centroid always going to be bigger?
Yeah. Mm-hmm. Vertex to centroid always is. And there's a way to prove that, but we're not going to
Even if
prove
it
it.
looks small?
Yeah. She's thinking. Got X game modes today. All right, so these two, blue and orange, are going to add up to the green, right? So let's write that. Oh my God, he's on X game mode. One of these days, mine will be completely forgotten, and then no one will ever understand me. It's how I learn to communicate with people. All right. So now they're on the same side. So we have x and we're adding 2x. That's the same as just what? X and 2x is the same as what? 1x and 2x is the same as? 3x, right? And 3 plus 6 is the same as? 9. That's all. They're already on the same side. No trickery here. No, subtracting to move them around. They're already there, right? Just put them together. All right, how do we solve the problem like Maria? What do you want to do?
Subtract the 9.
We can subtract 9. There's 2 different ways of doing this. We have the Eads method, right? Nothing wrong with this. We have 3x plus 9 equals 36, and he says I'll subtract 9. When I do that to both sides, I get 27. And then what would you do, Mr. Eads?
Divide it.
Yeah, divide everything by 3. And now there's only one thing on this side. Remember when we divide everything? So that's just going to be 9. That's x. That's what they wanted, right? Value of x. So we're done. The other way to do it, there's no rules about you have to subtract first and then divide. It's usually good to do that because when you divide stuff, you got to divide everything, right? But in this case, look, if I divide 3 by 3, that comes out evenly, right? Comes out to 1. I have to divide everything, so I also got to divide the 9. What's 9 divided by 3? 3. What's 36 divided by 3?
4.
Close. Actually, no, it's not. Sorry, I was thinking in reverse. 30. What's if I told you 30 divided by 3, what would it be?
10.
So what's 36 divided by 3?
12.
12. 2 more 3s, right? Does that make sense? 10 times 3 is 30. So 2 more 3s gets us 36, right? So 12. So here's what I'm going to do. I'm going to divide everything by 3, and I get this. Remember, when we divide or multiply, every term gets hit. Not just both sides, but every term. So this gets divided by 3, this gets divided by 3, and that gets divided by 3. Then I can subtract 3 and get 9. Same thing, right? Usually we want to subtract first, because then when we divide, we only have to divide one thing, right?
Yeah, I think I did it wrong.
Which way did you try? Did you try the
I
Eads
did
method?
Eads way.
Okay.
But
so
I divided 9 by 36 on
Oh, yeah, we're
But you're
subtracting,
supposed to- But
right?
you're supposed to divide like the 3
Yeah.
instead of the end.
We divide to separate. See how we needed to separate the 3 from the x, right?
Yeah.
So we divide to get rid of it, right? It's
Yeah,
opposite
I
multiply.
did it backwards.
Yeah, that's cool. Yep. When we move stuff, we're either adding or subtracting. When we're separating, we're dividing, right? So we have x equals 9. Finally, an answer that isn't 6. Although I guess the last one was 9.5 or 9 halves. Let's look at 7. BF. Aww. It's 36 3x plus 2. Here's BF. BD. It's 5x. Find the value of x. First of all, what's going to be the bigger segment, BF or FD? BF, not just because it looks bigger, but because vertex to centroid is always the bigger part. Vertex to the centroid is always the bigger part, okay? So that's the bigger part. That means that's the smaller part. That's going to be half, right? Small one stepping in? So we got to divide everything by 2. So the 3x is going to get divided by 2, and the 2 is going to get divided by 2. Doc, what's 3 divided by 2?
3 over 2.
That's right, so we have 3 over 2 x's, right? We had 3 x's, now we've got 3 over 2 x's. We divided it by 2. That's 1.5, right? 3 halves, half plus a half is a half. That's 1.5. And then we divide everything by 2. Don't forget to divide that 2. What's 2 divided by 2? Whole 1. Blue and green make red, at least in here, right? If we add those two up, they should equal 5x. So 3/2 x plus 1 plus the blue part, which is 3x plus 2. Should equal 5 x's. That's a lot of x's. Anybody top that? I cannot. All right, well, let's put stuff together. We got a 1 and a 2 over here. They're already on the same side, so let's just put them together. What's 1 plus 2?
3.
3, right? We got a bunch of x's over here, but do they have common denominators? We're adding halves to whole numbers, right? Got to change that. So we've got 3 halves x. What's another way to write 3? How many halves are in the number 3? 3 halves in the number 3? 6 halves, right? And when you write it, 6 divided by 2, is that 3? Right? Fractions are just division, right? So if you write a fraction and say it's the same thing as something, check it. 6 divided by 2 is 3. Yeah, every day, right?
So it'll be 9.
So we didn't change the problem, which made it look different. So we got 3 halves plus 6 halves. How many halves do I have, Eads? 9 halves. Don't forget your x's. Stalk them on Instagram. All right, now we got to get our x's together. Terrible idea in real life, great idea in math. Let's move the 9 halves over. If I'm moving stuff, I either add or subtract, right? I want to move this whole thing over. I'm not separating it from the x. I want to put my x's together, right? So the whole thing's moving. Right now it's positive. Right? When I move, I either add or subtract. So what am I going to do? Subtract. So I'm going to write it out just so you see what's going on. Right? Is that cool? Now, I can't combine those because they don't have common denominators, right? So we need to think, how many halves are in the number 5? 10 halves, right? Because 10 divided by 2 is 5. You look like a genius. But it's just how you think about it. Makes it a lot easier. So if I've got 10 halves and I subtract 9 halves, how many halves do I end up with? 1/2, right? Now we're here. Well, half of x is 3, so all of x must be 6. But to prove that algebraically, how do we get rid of this half? Right? It's times a half, right? Half times x. We can divide by a half, but dividing by a fraction is gross, so we multiply by the reciprocal.
So 3.
What's the reciprocal of a half?
2 over 1.
2 over 1, which is just
2.
2. So we're going to multiply by 2 over 1 to both sides. Or 2, whatever you want to think of it as, right? And so that's going to get us x. See how we multiplied by the flip? Right, we can divide by a half, which is gross, or we can multiply by the reciprocal, which in this case is just 2, right? And doesn't it make sense when we multiply a half by 2, we get 1x, right? Half double, it's going to be 1. We do it to this side. This says 3 times 2, what's that? Right, we multiply by the top, and we divide by the bottom. 3 times 2 is 6. What's 6 divided by 1? 6, right?
Lots of 6s.
Lots of 6s. Did they want us to find the value of x, or did they want us to find a specific segment?
Oh my gosh, I found the wrong one. It went down so far.
Twinsies.
It was like way weird. Like, there's nothing.
Does everybody understand the concept of we multiply by the top and divide by the bottom? Right? That's the idea. Fractions don't have to be scary. They really don't. Hey, they can be, but they don't have to. Find EF. So we're looking for EF. So I'm going to write that down before I forget. EF equals is what I want to answer, right? So my answer is going to go right here. BE is 3x minus 3. BE is all this, right? And EF, well, that's 2x minus 6. That's this. All right, let's check. Which is bigger, EF or FB? Don't just go off of looks.
FB.
FB, because it's going from the what to the what? Vertex to the centroid. Spread it over here. All right. This guy's going to be double, right? Median theorem. Why can't I say that? Median theorem. The ending in the N and then ending in the M. That's confusing me. So whatever this is, we double it and get that, right? So if I told you this was -6, we double it and get that -12, right? But everything gets doubled. So instead of 2x's, how many x's am I going to have? 4 x's. Instead of -6, I'm going to have -12. Green and blue in here is making red, right? So let's write it. 2x minus 6 plus 4x minus 12 equals 3x minus 3. I'm going to stop right there. You can solve that one on your own. Get x on its own and then plug it into EF, right? So get all your stuff together like we've been doing. 6x's, -18. Put stuff together. Let's move on. Skip 9. Look at 10. Ooh, blast from the past. Find the measure of each angle. Remember some exterior angles, remote interior, right? This angle and these two are related. These two guys add up to 120. Why? Because look, what's left over here? That's 180. So what's left over? 120 and what's the orange?
70.
What's 180 minus 120? 60.
70 is the answer.
Right? 180 total in here, right? That's 110. What's 180 minus 110? 70. Now notice, what's 70 plus 50? 120, right? So see how these two add up to this guy? Has to be, because those two, right, are going to add with this to make 180. And this are going to add to 180. Maddie, you okay with that? That part? Those two make 180, right? So that's 60. These two and this all make 180. So that's 110. What's left over must be 70. Or, if you know, these two are the far away angles, and that's the exterior, right? These two always add up to this. So what plus 50 gets 120? So I do 120 minus 50, and I get 70. That's another way to do it. Look at 11. Let's use alternate exterior, or not alternate exterior. Let's use exterior angle theorem. This guy, we know, is going to be equal to these two added together, right? So what's 140 minus 45? Let's do that in our heads. What's 140 minus 40?
95.
It's 100, and then we subtract 5 more, 95. Calm down, okay? Relax. So it's 95. You could have also done it this way and said that's 40, that's 45, 95 left over. Right? Another way to do it would be to say, look, linear pair, right? Another way to do it would be to say linear pair. That means this is 40, right? You follow me here? Linear pair, that must be 40, right? That's another way to do it. And then we got 40 and 45 makes 85. 180 minus 85. Maddie, 180 minus 85. 180 minus 85. Subtract 80, then subtract 5. 180 minus 85.
85.
Try again. 95, right?
95.
It's okay. 180 minus 85. Do 180 minus 80. 100. Subtract 5 more. 95.
Oh, yeah.
Yep. I did the same. I did it this way. Did the same thing. All right.
Okay, you're gonna want to just to write it down there, you're gonna want to write the measure of angle E equals 95.
Write it on there for now. That's fine with me. That's fine with me.
But I mean for the quiz.
That's fine with me. Writing it on there. That's fine. That will be persnickety. Not for this one, at least. All right. This is the external angle, right? These are our two remote interior. What must this angle be?
Isn't it the sum of the? I can't remember what it's called.
The remote interior
Yeah.
angles, the far away interior angles. Yeah, I love how you said sum. That's great. So we're going to add those together, right? 70 and 50. The way I'm going to think of that is 60 and 60. You know how I'm doing that? I'm taking 10 from the 70 and moving it over. So that's a 60, and that becomes a 60. Small 7 in there? 60 and 60 is 120. I can do 60 and 60 in my head really easy. I always screw up 50 and 70. I can think 5 and 7 makes 12. Oh, okay, right, 120. I like moving that over and thinking 60 and 60. Right? You can check your work. If that's 120, what does the orange angle have to be?
60.
Right? And does 60, 50, and 70 make 180? Yeah, it does, because 60, and 60. Gotta think of that one. Let's move on. Number 13. Here we go. Now we've got measure of angle S. That's what we're looking for. So I'm going to write measure of angle S. So I don't forget, I will mark off on this one if you don't write measure of angle S equals. Okay? For question marks and stuff like that, whatever, that's not really official stuff. Right? This is for real. So measure of angle S is what we're looking for. It's this guy. That angle measure goes with this. I'll make sure to draw it better on the quiz. I'm sorry. Those go together. So don't tell me it equals 3x plus 4. Great. I want to know what it actually is, right? After we get x, plug it back in, right? Okay. So if this is 140, that's 140. What's the relationship between this angle and these two?
Those two add up to that?
Yep, these two add up to this guy. So let's write that. 3x plus 4 plus 8x plus 4 should equal 140, right? Right? This is where this can become useful, I think. So now, 8x and 3x are on the same side, so I'm just going to combine those. How many x's is that total? 11 x's. A lot of x's. 2 4s make 8. I just solved a problem like Maria. We could divide everything by 11, but like, how about no? Right? That would not come out nicely, so I'd rather not. How about we subtract 8 first? Much like Kanye, we're going to get the prenup before we divide things up in the divorce, right? Move everything out. Subtract that 8. What's 140 minus 8? 132. Now we divide by 11. Doc, what's 132 divided by 11?
Couldn't tell.
132 over 11.
Oh, duh.
Now the question is, does that come out evenly or does it not?
I thought it was 12. I'm sorry.
No, you don't need to be sorry. If we do 10 times 12, we get 120, so 11 times 12 is 132. Yeah.
Can I get her?
You're right, it's 12. Guys, I don't know what it is, but if I do 10 times 11, I get 110, right? 11 times 11, add 11 on top of that, 121. Add 11 again, 132 is what I get, so it's going to be 12. Again, the way I did that is I did 11 times 10 in my head. That's 110, right? That's 11 times 10, right? Right? That's how I did it in my head. 11 times 10 is 110. Then what does 11 times 11 got to be?
1.
Add 11 to that, right? And I get 1, 2, 1. Okay. And then 11 times 12 gets me 1, 3, 2. So it must be 132 divided by 11 is 12. So x is 12, and I'm done, right?
And then I measure x.
Ooh, that's right, angle measure. So we plug in 12 to this. Let's do 3 times 12 in our heads. What's 3 times 10?
30.
What's 3 times 2? So it's 36, right? Then we add 4. 40.
Oh.
36 plus 4 is 40.
Oh yeah, I did it wrong.
Yeah, that's okay.
I knew it was.
Again, we're not here to be calculators, guys. We're here to think about numbers differently, right? So if you make a mistake, no one cares. No one cares. Especially if you can go, oh, I see what I did wrong, right? Happens. That's 40 degrees. Angle YDC. Well, let's find angle YDC. Looks like angle YDC is this angle, right? So measure of angle YDC is what I want. Don't tell me it's 15x plus 5, right? Plug in for x and then tell me. That's a 5 there. The little m is for measure of that angle. Sorry, I should have meant an angle symbol.
Oh, so confused.
Yeah, my bad. Measure of angle YDC. Yep. Okay, the measure of it. So degrees is what I want. All right. What do we know about YDC, that angle? 15x plus 5, right? What do we know about it?
C's 100.
C's 180. That angle.
No, 100. I mean,
I'm sorry. Yeah. Yeah, I get what you're saying. 180. Yep, they're going to be a linear pair. Yeah. It's not very helpful. But
Is it 15x plus 5 equal 80 plus 6?
Yeah. These two remote interior angles sum to this guy, right? Remote interior angle sum. So we know that's going to equal 80 plus 6x plus 6. Does everybody see that, right? The two remote angles add up to the exterior. So that's 86 on this side plus 6x. Does 6 go into 86? We could divide everything by 6 right now. The answer is no, because 6 doesn't go into 80, right? So we can't go into 86. Let's put stuff together, though. Let's get our x's together and stuff. So, want to move the 6x over? How do I do that? Subtract it. So 15x minus 6x, how many x's will I have left over? 9 x's. An improvement, to say the least. Then let's subtract that 5. Then we'll get 81. Ooh. And then how do we separate the 9 from the x? Divide by 9. What's 81 divided by 9? 9 all day. And we're done. That's it. No, it's not. We got to go back and plug it in. Let's do it in our heads. We're plugging it into this, right? 15x plus 5. What's 9 times 15? We'll do it in our heads. What's 9 times 10? Good. What's 9 times 5? What's 90 plus 45? Let me write that down. I'm going to think of this in my head as 90 plus 10 plus 35. What's 90 and 10? 100. Do you see how I did that? I can think of 100 in my head plus 35, right? 135. Now I got to add that last 5, right? 9 times 15 was 135, right? Because I did 9 times 10 and got 90.
Oh,
9 times 5 is 45, right? Now I got to add that last 5. So it's going to be 140. Not bad. Again, if you need a calculator tomorrow, raise your hand and I will be your calculator. But in general, those are some ways you can think about it, okay? And that's it. Yes,
Can I come in like in the morning tomorrow just to review?
please. I'll be here at 7:30 at the latest. I don't want to promise anybody any earlier than that. I'll probably be here earlier, but still.
I get here at like 7.
Okay, we can come in real quick. I'm gonna have a lot of people coming in. So the earlier you get here, the more attention I can give you. But that's the quiz, guys. We've got remote interior angles, right? Two far away ones add up to the exterior. And then we got median stuff. That's it. That's all she wrote. Make sure you're marking your diagrams very carefully, right? If they're medians, then you can say that these guys are congruent and these guys are congruent, right? Make sure you mark them.
It's 7 questions.
Make sure you know which is the big side and which is the small side. Sometimes they can look like they're the same, right? Be careful with that. What's the bigger side of the median? Vertex to centroid or midpoint to centroid?
Midpoint to centroid.
Good guess, but nope, vertex to centroid. Okay, the pointy part to the centroid is always bigger.
That's what I said.
That's what he said. I misheard. It's my bad. We got it on tape. We know what happens. Vertex to centroid. That's all I got for you guys today. We skipped 9. You want to go back and do it or no?
No.
I'm
Yeah?
gonna tell you something, actually.
You gotta tell me.
Yeah, but I don't remember what.
I don't owe you money or anything, do I?
No.
Okay. Because I believe you. You told me.
He's doing it.
What do you want to do about it?
They can come back there.
Remember, the rule is do when I'm not looking.
Oh,
Otherwise,
I was
gotta
in the
report
Walmart yesterday,
Yeah?
and I thought about you. There's
Oh,
these
really?
tires in there.